So hello to everyone. Welcome to session 1 of our course on Big Data and Hadoop. My name is Anjana and I'm part of the team here at Know Big Data. I'll take a few minutes to take you through what to expect of this session and to introduce you to Know Big Data. Please make use of this time to send in a quick one-liner introducing yourselves. So this session is about 3 hours long. The first half will focus on what big data is and why it is relevant in today's world, and the second half on Hadoop architecture. There will be a 10-minute break about an hour and a half into the session. As mentioned, please use the chat window to introduce yourselves. This will be your primary mode of communication with the instructor for this session. Although this is session 1 of our 11-part course for Big Data and Hadoop, it will suffice on its own as an introduction to big data technologies. Since this is an introductory session, we keep this open to all and have a lot of attendees, which is why everyone is muted. So our instructor will read out a question before answering it and will do his best to answer all the queries posed. You could help the instructor respond to more queries by keeping the messages short and avoiding chat language. For those who will be taking up the rest of the course from the next session will have fewer attendees and we will be using a different, more interactive tool. This session is being recorded, so those who are making notes can sit back and relax. We will be making this presentation and recording to everyone. So before introducing you to Big Data and Hadoop, let me introduce you to Know Big Data. Our primary focus is online trainings relating to big data and data sciences. We are thrilled to provide you with instructors who are industry experts. You will see that for yourselves during the session itself. What we mean by an expert. As part of the course, we provide access to Cloud Labs, which is a cluster that you can use to play around with whatever you learn during the classes. This feature is unique to Know Big Data and gives you a real feel of how things work at organizations that use big data. Course takers are also given lifetime access to our learning management system, which will include all the presentations, recordings, assignments, and project work. You will be able to use our Cloud Labs that I mentioned earlier to complete a real-life project, at the end of which you will receive a certificate which can be shared on social media, including LinkedIn. You will also be part of our alumni group. We like to refer to it as Knows Big Data, which will keep you posted of new job opportunities and help you stay updated and connected. So let us move on to today's session. Our instructor today is Sandeep Giri. I will let him introduce himself and take it over from here. Have a great session.
Hello everyone. Can you hear me clearly? Answer by typing in the questions window. Great. So Atanu can hear, Binod can hear, and Nirvan can hear, Nirav can hear, Sandeep can hear. Great. All right. So we have a great set of audience today. Let's not call audience, let's call them participant in this because all of you will be asking a lot of questions. And if not, then you should be asking a lot of questions. Okay. So plan to ask as many as questions possible to clear your doubts. And all right, so let's begin with introducing yourselves. So I'll introduce myself and then I'll read out your introductions and then we will start the session. Okay, so please introduce if you have not already. Atanu, Gunjan, Anand, and Meenakshi, Sandeep, Binod, and Gunjan have already introduced. So please introduce yourself by typing your introduction in questions window. And in the meantime, let me introduce myself. All right. So I'm Sandeep Giri. I did my graduation in from IIT Roorkee in 2002, and afterwards I joined a company called DE Shaw. DE Shaw specializes in D, at DE Shaw. Uh, we were uh, we were part of the big data even when the term was coined. We used to call it grid computing, or cluster computing, or distributed computing. All right. So we were handling humongous data, data in hundreds of terabytes in 2002. All right. And in 2006, I founded a company called Tbits Global, where we built a document management system similar on the lines of somewhere around MongoDB. Then at InMobi in 2012, I joined InMobi, and there we built a recommender after churning around 200 terabyte of data. Okay. So at InMobi, instead of displaying ad in your mobile app, we started displaying the recommendations for you, the application recommendations which you can install. Then uh, I joined Amazon for some time, and I built really high throughput system for image optimization in Amazon.com on the lines of Apache Storm. All right. So that's about me. Let me read out your introductions. We have a great set of audience today, or great set of participants today. So we have Atanu. He's working in accretive health and has 9 years of experience and working with .NET technology. Great, great to know you, Atanu. I'm sure you will like these sessions. We have Anant. Anant is a software engineer and he is thanking us for organizing this session. So, Anand, feel free to introduce you a little bit more. All right. So, we have Sandeep Tengale. He is from Bangalore. And okay, we have Binod. Binod is working as technical manager at Novel in Bangalore. And they have plans to introduce big data concept in our existing projects. Great. Great. I'm sure, Binod, you will understand the concepts and everything behind big data. And I'll make sure that it is uh, as simple as possible. All right. So stay tuned. And by the end of this session, I hope that you will be able to get more insights. All right. We have Gunjan. Gunjan is having 8.7 years of experience in IT with telecom and PLM and mobility. Great. Great. We have a great set of audience. We have Nirav. Nirav is from eBay and has 15 years of experience and working in Java, virtualization, and cloud computing. Brilliant. You will have definitely you will definitely have a clear idea about big data after this, and probably it will add a lot of value to your current profile. All right. We have Prabhakaran. Prabhakaran is from Chennai and working as a business analyst in the area of performance management and has got 4 years of experience. Great. Great to know you, Prabhakaran. We have Aarti. Aarti working as at Credit Sys. I don't know how to pronounce that. As AVP. Interested to learn big data and where it can be used. Great. Great. I'm sure you will have more information and more insights into your question about where it can be used and what it is. All right. We have Minakshi. Minakshi is in SAP in sales, having 9 years of experience. Great, great. All right. And also, in addition to Gunjan's earlier introduction, Gunjan has an experience of C, C++, Unix, Core, Java, Oracle. Brilliant, brilliant. It's a great profile. And most of the tools under Big Data umbrella, you are going to be okay with. All right. So Shrikant, the microphone, his question is his microphone is not working. So Shrikant, just okay, you already introduced yourself by typing. So to everyone, we will keep the microphone off because it becomes too much of voice collision. And please ask your questions by typing. All right. So that also means that you do not have to wait for me to finish. You can keep on typing your questions, and as and when I'm getting time, I'll respond to those. All right. We have Anant. Anant is working in Java technology with 4+ years of experience and is working in defense domain in Rolta. Great. We have Srikanth. Srikanth is a developer with 1 year's experience and working on Java. Brilliant. So, so we have a great set of participants, and with a different backgrounds, and I'm sure that this session will be able to add some benefit to their time. All right. Now, okay. In today's session, we will we will go through what is the big data, the basics of it, and then we'll talk about what is Hadoop, what are the components under umbrella of Hadoop, and then we will go into the details of HDFS. All right. So before I begin, let's start with an interactive discussion. And we have one more person whose introduction is pending. So we have Yashwant. Yashwant is having 1.5 years of experience and working on Insta Health solutions, having knowledge of Java and J2E. Great, great. Welcome, Yashwant. And yeah, so my question to all of you is, what exactly do you understand so far? What is your understanding? So, what is your understanding of big data? Yes, feel free to answer. Binod's question is, when data amount is very high and not able to process by simple programming language like Java or .NET. Um, Actually, you can say it like this: when the data amount is very high, but because the and you're not able to process using normal tools. Although you will notice that in under big data also you will be using those usual programming languages like Java or maybe .NET. All right. Yashwant's question is, I don't know about big data, why and where to use. You will get to know why after this discussion. Okay. So nothing to worry, Yashwant. Here the idea is whatever you know about big data, you should tell. What is your understanding? All right. Anand's point is big data is a new technology primarily used in business analytics. All right. That is Anand's question. Nirav is saying that it's a huge and structured data coming from various sources. All right. So, yes, that is correct. And even Anand's question is correct. Gunjan's point is, as per my understanding, big data means large amount of data, more than terabytes. Okay, that's partly correct, yes. We have Prabhakar's. It's a collection of raw data. That is Prabhakaran. Okay, a raw data which is unstructured. All right. Now we have Shrikant's point. Shrikant is saying that big data is about dealing with large data, structured or unstructured. Good. Like a pet, like logs. Good, good. So big data is a concept to help organizations to collect, process, and analyze structured and unstructured data. All right. So that is Meenakshi's point. Okay. So Binod is saying big data is huge and structured. Deepthi is saying big data is extremely large data set that may be used to develop business. Rajkumar is saying big data is technology that can store huge amount of data and help us retrieve. Good. All right. So all of you are very close in your definition. So I'll just make it concrete. We have Atanu's answer, large amount of data which can be measured. Great. Which cannot. So yeah. So most of your answers are very close. All right. So also note that this session is being recorded and will be shared after this session with you. Okay, the video will be shared after this session with you along with the presentation. So nothing to worry. All right, nothing to worry, and no need to take a screenshot or anything. We will share the everything with you. All right. But if you like to take notes for your understanding, feel free to do so. All right. So all of you have answered the question very well, and let me put down what I think about it. So this is the definition we will go by. We will stay with our definition all throughout 11 sessions. So what exactly is big data? In very simple words, big data is data of very big size. Data of very big size, so big that you cannot process with usual tools. What do I mean by usual tools? Usual tools means your normal file systems like you have on your computer, your normal databases such as Oracle, Microsoft SQL, or any other databases. And to handle such data, you require distributed architecture. What does it mean by distributed architecture? We will talk in a minute. And the data can be of any form, whether structured or unstructured. It can be of any form. All right. So we'll talk about these two definitions, distributed architecture and structured or unstructured. All right. So in simple words, distributed means a group of networked computers interacting with each other to achieve a common goal that is distributed. And sometimes you will also see something called parallel computing. Either distributed means multiple computers connected to each other to achieve a common goal. In parallel computing, you have multiple processors and a common memory to achieve something. Okay, so here there's a singular memory and there's a multiple processors in parallel computing. That's not what we are going to focus upon. All the tools, all the sessions that are covered under big data, they all have a common attribute called distributed computing, meaning most such data which you cannot handle with single computer and you require multiple computers to handle such data, then we call that kind of a data as big data. All right, now if you have a look, what exactly is structured and unstructured data? Okay, we'll go back to our definition after this. So structured data means you know exactly what are the fields in your input data and what are their data types. All right, such as your database or sometimes your spreadsheet also, because most of the time in spreadsheet you have the clarity of data types. So when you know that what are the fields in your input and what are their data types, you call your data as structured data. In case you know the fields, what are the fields in your input data, but you don't know their data types, then you call your data as semi-structured data. Semi-structured means such as say, examples of semi-structured data is CSV, comma separated files. If you have heard about comma separated files, comma separated values, CSV, and maybe XML. So when you don't know the data type of the input fields, then but you know what are the fields in the input, then you call your data as semi-structured data. All right. Then we have unstructured data. Unstructured data means neither you know what are the fields in the input, nor you know the data types in the input field. Okay. So so these are the data types, and again I'm going back to the definition. So when we talk about big data is such a huge data for which we require distributed computing. Distributed computing means networked computers working together. When we require multiple computers networked together to solve your problem, we call it as big data. All right. Anand's question is that can RDBMS not store huge data? That's a correct point. So although it appears that these databases store humongous data, okay, but when it comes to few hundred terabytes of data, most of the existing databases falter. Even if you are able to store data into these databases, the retrieval time becomes so high that it becomes absolutely useless to store data in the existing systems. Okay, reason being there are multitude of problems in storing humongous data into a single computer. The first one being I'll talk about these components. What becomes a problem? It's not necessarily the software which becomes the bottleneck. It is mostly the hardware. All right, and most of the existing databases do not work in a perfect distributed manner. That is why there was a need to reinvent most of these softwares so that they can run parallelly on multitude of computers. All right. I hope I made sense, Anant. Anant. Now, Meenakshi's point is, what does it mean to have data handled by multiple computers? Yes, that's what it means. Okay. And her next question is, what is data type? Data type is, so what does she mean by data type is, her question is, when we talked about here, here, fields data type, right? What does it mean? So if you have been into your relational databases background, so if you remember that when we create a table in Microsoft SQL, in any database, you create a table, you define what are the fields in your input, what are the fields in this table, and what are the data types. You clearly define those. So if you are given a database table, you have a thorough clarity on what exactly is what are the fields in this data and what is their data type. So that is structured data, right? So I hope that answers your question regarding data types. So similarly, a data type could be float, string, boolean, or it could be, okay, it could be a number, it could be string, and it could be a boolean flag, true or false, okay, or it could be a complex data type. So Tanigawel's question is that, so okay, all right. So Ganesh's question is, that's called a clusters, right? Yes. So cluster computing, distributed computing, and there are multiple names for it. Grid computing. They are mostly the the same word. It's their connotation is same. All right. So cluster computing, distributed computing, or your grid computing, they all mean same. Okay. All right. So yes, Yashwant, you want to say something about image? All right, great. So you all understand what did I mean by big data. Now this is a traditional definition, and this is something which IBM has been writing about. So what the way they define big data is there are a few characteristics, and because of these characteristics, you your data ends up being such that you cannot use your traditional systems. You will have to use a distributed computing architecture to solve your problem. All right. Now let's see what it is. So it could be a volume of the data, it could be velocity of the data, it could be variety of the data, or it can be veracity of the data that might make it impossible to handle the data using traditional tools. All right. So first one is volume. What does it mean by volume? Gigabytes, terabytes, petabyte, humongous storage of the data. Okay, that's how we characterize the the volume. Okay, so you can say that when the volume goes really high, such as hundreds of terabytes, then your existing system are mostly useless. All right. Velocity. So you can think about velocity like, okay, let me go back to my volume definition. Let's take in these words in context of Facebook. So every day, a lot of people upload lot of images. At the end of day or at the end of month, Facebook accumulates hundreds of terabytes of data. Okay, so that is volume. Per second, every user keep on refreshing their Facebook news feed, right? Every time we keep on refreshing it, requesting Facebook for news feed. Now imagine that there are millions of users doing it per second. Okay, every second, millions of users send a request to Facebook to see their news feed. So, meaning there are millions of requests going to Facebook, and that is what is known as velocity. All right, that is what is known as velocity. All right, now third one is variety. So you may not be able to solve a problem maybe because using your existing system, maybe because the data is too huge, or there are too many requests coming per second, or the kind of data may be too complex. When we call variety, let's look at what it is. So variety means maybe your data is so complex, or the problem you are trying to solve is really, really complex. All right. Such as, take a case of when we talk about handling lot of data. Imagine that at Facebook you have to analyze each and every image being uploaded in order to tag them. Now, since the data is really complex, it takes a lot of time, and if you have to do it parallelly per second, it requires a lot of computing, and you cannot definitely do it on a single computer. So that is variety. So due to the nature of problem, or due to the nature of the data you are handling, if you end up realizing that your existing databases cannot be used and you require a distributed architecture, then you say that my problem is big data problem, and the kind of data am I handling is big data. All right. The fourth one is veracity. Veracity is something, when you do not know when you do not know whether to keep a data or to discard it. And because of this confusion or these kind of doubtfulness, you end up accumulating a lots and lots of data. And basically veracity leads to lot of volume. Okay, when you are not sure whether to keep a set of data or just drop it, so end result of such confusion is that you end up storing a lot of data, and when you have a lot of data, again you end up with a lot of volume, right? Now example for veracity would be that you got the data of, say, you wanted the temperature data of all the cities. All right, you got, say, 15 kind of data sets from 15 different vendors. One is giving you in the form of geographical coordinates, GPS coordinates, and the temperature. The other one is giving you zip code, but giving you per second data across the globe. And third one may be giving you per city and some other coordinate. Now, now if you look at it, there are multitude of data sets right now representing the same data. Effectively, you are having 15 times data, and hence you are having humongous volume to handle. Now, even if you had to analyze these 15 data sets to figure out which data set is important, you will require a big data kind of tools. All right. So these are the four common attributes of big data, and IBM has probably added one more this year called value, and they keep on adding these things. That does not make much of a difference. This definition is good when you're going for interviews, but in real life, when you are to decide how to solve your problem, you need to think in terms of whether one computer can solve my problem or not. All right, let's move ahead. Before that, I'd like to answer one question. Deepti's question: is big data related to cloud computing? If it is yes, just wanted to know how it is related to cloud computing. All right, so cloud computing, if you look at it, is nothing but computer at somebody else's place. And it could be a single computer, it could be multitude of computers, meaning multiple computers. So essentially, a cloud means a bunch of computers at somebody else's location. While distributed computing is whether the data is on your own network locally, on your own PCs which you have connected, or data is on somewhere else. All right. So cloud computing and uh, distributed computing intersect in a way that mostly when you run a distributed system, which is multiple computers, when you run multiple computers, you generally like to give it to professionals and let it run over cloud. Because when you add more and more computers, handling physical hardware becomes very difficult, and therefore it makes sense to run a distributed computing architecture on the cloud. All right, I hope you understand how is the cloud computing related to distributed computing. All right, then why I replaced distributed computing in place of big data, you must have understood from the definition. Okay. All right, so idea is that so you can we are talking, whenever we talk about big data means you require multiple computers to solve your problem. Now you can install these computers locally in your garage, in your own data center, or you can put these computers at somebody else's data center. When you put it on somebody else's data center, we call it cloud computing. All right. And the other aspect is that on the cloud computing, managing the hardware is actually easier because the computer is not really a physical hardware. It is generally the virtual computer inside another computers. All right. So that way, if you have thousands of computers running on somebody else's cluster, it becomes easier to manage them. All right. I hope you got the answer now. So Tanika Well's question is that if so, if everyone turned their DB to HDFS, cloud technology will die due to the cost it takes. Good point. But the answer is no, it will not. You will realize that the existing computers which people have are mostly, you know, are being used at a very low usage. Okay. If why? Because if even if you have 50 computers and you have a single database, that database will only consume one computer's resources. Other computers' resources will be free, and it's very difficult to actually distribute in existing system. So basically, distributed computing makes use of your computers properly, as such as it distributes the load uniformly across your cluster and solves your problem. Okay? It does not mean that we are using thousands of computer when we could use only one computer. No. All right? We are just utilizing your network in order to solve the problem. In case your problems could be solved
using your existing database, existing single computer database, then there is no point in going for a big data kind of architecture. All right. So that's also a thumb rule to live by. If your problem can be solved using existing architecture, there is no point, absolutely no point in moving your infrastructure to big data. All right. So Gunjan is saying, so can we set up required software on local machine or not? Of course you can set up, but it will not give you the real feel. So, for example, in our session 2, we will guide you how to access an HDFS. So you can definitely install these infrastructure to local machine, okay? And we will show you how to do that. But it does not give you the feel, because unless and until you are able to realize that my computation is being done, my function, the program I wrote is being executed parallelly on multiple computers, and unless and until you can see that, you will not really feel the need of all of these distributed computing architectures. You will always feel that what's the point. Okay. Therefore, to make really a sense of any of these big data tools, it only makes sense if you have multiple computers. Okay. If you have a requirement which needs multiple computers. Otherwise there's no point. Gunjan, I hope I make sense. All right. So although you can set up on local machine, definitely, but you will not really realize the the gist of the distributed computing unless until you see your code being executed on multiple computers simultaneously. All right. The way in a server client application, if you have server and client on the same machine, you do not really realize that the difference in architecture. All right. So somebody was making a web-based solution. I remember it so well. Somebody was making a web-based solution for instead of ATM card, he wanted to use a floppy disk. He was able to give a brilliant demo when the server and client was on the same machine. So he gave a demo to me, keeping server client on the same machine, inserted the floppy drive into the machine. I asked that who is handling the floppy drive, the server or the client? Okay. So he was under the impression that this whole model can work brilliantly because he is able to make it work on a single computer. But in reality, client which is a browser cannot handle a floppy disk, right? So in the similar manner, here in a server client architecture, if you try to run server and client on the same machine, generally you will not really get a feel of it. Okay. Similarly, if you are running a distributed architecture, you are having few computers. Unless and until you try it on a real cluster, having at least 2 to 3 computers, you will not really feel it. Great. All right, Gunjan. Yeah, good, good. All right. So again, just to check whether you are with me or you are awake. Yeah. So how many bytes are there in a petabyte? So what do you think? Quickly, anybody? First answer and I'll start. All right. So Gunjan says it is 1024 terabytes. Anybody else? Taningawal says that it is 4096 bytes in a petabyte. Is it? Okay, Srikanth also says 1024 terabytes. All right, Anand says 1024 exabytes. Mm, I doubt. All right. Nirav says 1024 terabytes, 1000 terabytes. All right. Prabhakaran says 10 lakh gigabyte. Vinod says big number and he has copied from internet. Okay. So let me just count the numbers. Good. Yeah. All right. So yeah. So it is basically 1024 terabytes. Gunjan, you were right in the first way. And all right. So in general, we can simply say 15 zeros. That should be good enough. And the rest of the things do not matter too much when it comes to that bigger number. So you can simply say 15 zeros and that should be good enough. Okay. This is a general table, the way we remember it. 1 kilobyte has 1024 bytes, mega has 1024 kilo, and so on. Okay. So this is the way you can remember. And note that a byte is a big number. Byte can actually store 250 states. Okay. Byte can store 256 states. Meaning if you have to represent 256 different kind of things, you can use a single byte. Yeah, 2 to the power 50, that is another way of saying. Good, Ajit. Thank you. All right, brilliant. So now we know what is a petabyte. My question now is 1 petabyte big data? 1 petabyte has 15 zeros, and big data we talked about is a data that cannot be easily handled on a single computer. We require distributed architecture. So do you think 1 petabyte is a big data? Meaning, do you think 1 petabyte is big enough data which you cannot handle on a single computer in a reasonable time? And what does it mean by handling? Let me explain that. We should be able to store this data and do basic processing. If this data is composed of numbers, we should be able to sum these numbers in a reasonable time. Okay? So anybody? Srikant says can be. Okay. So do you think 1 petabyte is a big data? Do you think handling 1 petabyte in reasonable time, we require a distributed computing architecture? Do we require multiple computers to handle 1 petabyte data? So Gunjan says yes. Anand says it is big data. Okay. And Anand says my PC's hard drive is only 1 terabyte. Okay. So Anand, even if you are humongously rich, even if I am very humongously rich and buy 1000 terabytes hard disk. First, there are no 1000 terabytes hard disk available in commercial space. There are only at most some 10 terabyte hard disk. Even if I buy such kind of so many hard disk, it will not be possible for me to connect it to the same computer. Even if I somehow connect it, the reading time of the hard disk will be horrible, will be very, very horrible. All right. Great, great. So almost everybody agrees with me that 1 petabyte data is big data. Thanigawal says that yes, single machine DB distributed in virtual, it is possible. That is SDFS. Vinod says, I do not think that having huge data will be called big data. Big data concept comes out if we can manage huge data in good performance. So whenever we say a problem, whenever we say can it handle or not, we always say that in a particular time frame. All right? We always say that can our computing infrastructure handle 1 petabyte data in a reasonable amount of time? It should not take 2 years to just sum up the numbers, right? So it's not only huge. I have taken this example because just a simple thumb rule, just for a simple use case, it's not only the volume of the data. There could be multiple other properties which can force you from single computers into a multitude of computers. Okay? So hope I have been able to answer your point. No? Feel free to. Yeah. So big data concept, whenever we go from a single computer to distributed computing architecture, we start calling it big data. Or let me put it this way, I, along with Apache Hadoop, will stick to the definition of big data as distributed computing architecture. All right? Yes, Vinod, feel free to ask if you have any doubt. Yeah? Right. So Binod's question is then where is the difference between distributed computer architecture versus Hadoop? Okay. So Hadoop is just one solution that tries to solve your problems by the way of distributed computing. There are many others. All right. So that is the difference. So almost all the components, if you study about Apache Hadoop, almost not almost, but every component that qualifies to become the member of Apache Hadoop, they need to be distributed computing. They need to be for distributed computing. All right. So the difference is that yes, you're correct. So his question is, can we say distributed architecture concept is big data concept? That is correct. That's the definition we will stick to. Okay, that's a definition I will stick to so that there is no doubt in what I'm talking about. All right. So we'll stick to the definition that big data concept means a distributed architecture concept. All right. Good. Good. All right, so now let me ask you a simple question. How much time does it take to read 1 terabyte of data? Anyone? So you have 1 terabyte data in your hard disk, in your normal hard drive, okay? And you are using the fastest possible hardware driver to read. There is no glitch in the software side. How much time do you think it is going to take? Anyone? Correct. Thank you, Atanu. It takes around 5 to 6 hours, right? So now, yes, correct. Thank you, Atanu. Yes, it takes around 5.5 to 6 hours. Now, the why I ask this question is that we talk about 1 terabyte data, and imagine that you have to process 1 terabyte of data. It sounds easy to say 1 petabyte data, but if just reading 1 terabyte data is taking 6 hours, imagine how much time it would take to read 1 petabyte data. It will take minimum 6,000 hours, right? And therefore 6,000 hours is too many hours. And in reality, if you just have to sum up the numbers, if you have to just sum up the numbers, as in you have 1 terabyte of data and you want to only do is find average of all the numbers, or just count the numbers, how many digits are there or how many lines are there in this 1 terabyte data. If you just have to count that how many times slash n or new line character has come in 1 terabyte data, it will take 6 hours. Irrespective of what piece of code are you using, minimum it will take 6 hours if you're using a hard drive. Now the question is that, is it acceptable? Is it okay in your business case that if just to find out, it just to count the number of lines in your data, in 1 terabyte data, if it takes 6 hours, is it acceptable to you? If it is not acceptable to you, you need to seek out a better solution. You need to seek out a solution which can run on multiple computers. And you note that here, when we talk about 6 hours, that it takes 6 hours to read, the computing system is not the programming environment is not a problem. Java is not the problem here. It's the hardware, it's the disk speed, it's the rate at which you can read from the disk, right? Therefore therefore it's not the fault of any of the programming component per se. All we need to figure out is how can we get this thing done using other so many computers in parallel. All right. So you should note that it is not the software's problem alone, it's the hardware. And okay, now let me take up your questions. So Binod, you got your question, you got your answer. And Yashwant says that it will take big time or server will not fetch in RDMS, might be timeout error. All right, that's correct. Okay, Gunjan Singh said maybe hours, that was correct. Using Java, it is very difficult to get some information from 1 TB, but we can do in big data. No, actually using Java, you can read 1 terabyte data. It's just that it will take too much of time. All right. So Meenakshi's question is, even high-end computers take 6 hours? Yes, even high-end computers take 6 hours. And trust me, even if you notch up the hard drive a little bit, you put more RPMs, you can only reduce from 6 hours to maybe 5.5 hours or maybe 5 hours. That's all. Okay. Tanigaval's question is that using SQL query might even led to timeout. That is very correct. I was yesterday only, I was, you know, going through one of the client's problem. It was a telecom company who have around 100 GB data per day accumulated for last 10 years. Okay. Now, every time they query that data, the database keeps on giving all kinds of timeout errors. All right. So is everybody with me so far? Great, great. So looks like everybody with me. All right. Now moving on. Why are we talking about big data and why did this story begin? The moment in 2002, this diagram is quite popular. So in 2002, the data suddenly started growing. Analog data is your normal physical books, your audio vinyl discs, and whatnot. So analog data did not expand too much. It actually uh, became lesser day by day. But digital data started exploding, meaning lot of digital data people started storing after 2002, and that's when we call it the beginning of digital age. Why did it happen so? The question is, the question is the why did it happen that way? Yeah, Tanika, well, everybody's mic is muted, so nothing to worry. Okay, the way we will communicate is by the way of typing. All right. All right. So why did this data explosion in digital arena became so huge after 2002? Okay. Why did it happen though? The answer is two. The answer is twofold. The first is hardware. The first is hardware. Other is computing. Meaning the one is hardware, other is connectivity. Okay. The on one hand, the hardware kept on becoming cheaper, faster, and smaller. On other hand, the the connectivity became more and more available. Now we have broadband, we have 3G, 2G, 4G, and we have Wi-Fi, and we have all sorts of more and more communication, such as Bluetooth and Bluetooth 2.5 gigahertz wireless, and there are so many more modes of communication as of today, right? So while on one hand, the hardware, the physical hardware, like camera, the 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 radio chip, everything has become smaller, cheaper, and faster. And even the battery has become far better. So that has led to a big invention called smartphones, a device in everybody's pocket. Okay, a big computer. The computer which we carry around as of today is equivalent to supercomputer of 2000s. Okay, in 1990s, whatever the supercomputer we had, that was hardly 1 gigahertz. Okay, and now we roam around with mobiles which are more than 1 gigahertz in power in our pocket, and we use it brilliantly for doing things like playing Angry Bird. All right. So yeah, so we have, because on one hand the devices became more and more popular, more and more powerful and smaller and faster. On other hand, the connectivity became higher. So you can think about connectivity like a multiplier of the data, or and the hardware like smartphone, you can think of data generator. So on one hand, the data generation became omnipresent everywhere, and on other hand, the ability to multiply this data to transmit to various sources becomes available. Okay, like for example, I am right now creating a data of around 1 gigabyte per hour. So at the end of it, I'll be transmitting around, maybe let's say, 1 gigabyte today by the way of this meeting. And but since you all are connected, so if there are 40 people in this session, that means I would have transferred around 40 gigabytes. All right. So that's another reason why the data has exploded so much after 2002. That's correct, Meenakshi. The availability and accessibility to phone, computers, and technology to everyone has led to accumulation of lot of data. Now, now before I move forward, I would like to quiz you a little bit more. Which components? Now we talked about that there is big data. The reason is that we there are so many generating sources as well as so many multipliers, which means uh, v- so many transfers are happening. Now, question to all of you is, when we handle big data, what are the challenges? What do you think? What do you think when we say computing? What are the components that impact computing? Is it CPU? Is it memory? Is it memory's read speed? I mean, the B is memory size. Memory means RAM, okay? RAM or whatever you want to call it. And disk speed, disk size, network speed, or all of above. What are the components that impact your computing ability? Think about any computing, okay? What are the components that impact your computing? Srikant says all of above. Great, great. So Meenakshi, all of these components impact the computing. Although your point was memory, I agree that memory impacts most amongst these components, because in a typical server, it would be the memory which is mostly busy, while rest of the resources are fairly free. Okay. So in most of the server environments, memory is the one which gets filled up generally. I'm not saying a hard fast rule. All right. So yes, all of the above, all of these tools actually impact computing. Most of us believed, have been tricked to think that it's only the CPU, it's only the processor which matter. Like we had been, I mean, this whole thing has been promoted by Intel specifically. Whenever we talked about computer, we always talked about, is it 1 gigahertz, is it 5 gigahertz, is it Intel, or is it AMD? So whenever the first thing we talk about a computer is these things, while if you in reality, if you notice, all of our computers are hardly using 1% time of our CPU. So CPU is essentially the most free thing in your computers, if you notice the graph, right? It is these other resources, specifically the memory, which basically becomes the bottleneck very quickly. Okay. To save the memory, we start writing the data to disk, and then disk starts becoming bottleneck. And if this disk starts becoming bottleneck, we start moving the data to the network disk, and then network becomes the bottleneck. Okay. So in general, uh, you can think of that these four are the pillars of the computing: the CPU, the RAM, and the network, and the disk size and speed. Okay. And we keep on moving the bottleneck from one place to another until at a point of time we realize that we cannot do anything. All right. So if our RAM becomes problem, we try to write the data onto disk at the cost of speed, because RAM is fairly faster. Now, so we start writing to the disk, and then this becomes bottleneck. Then we start writing to network, then network become bottleneck, and at a point of time we give up and say that our problem cannot be solved by using this computer. We need to figure out another ways. All right, make sense to all of you? All right, so we talked about the difficulties in handling your data using a single computer. All right, the only way we could solve this problem by using multiple computers, because no matter what, one computer's resource will become impossible bottleneck when we handle big data. And bottleneck in the sense that the time taken would take a lot of time. The time taken by computing will take many hours, and which is not something you can tolerate in production. All right. Now, before we move on to further technical details, let me go through why do we need to worry about churning so much of big data? Why does it have to offer us? Why does a big data has to offer us? What is it that the big data can offer while small data cannot offer? Most of you might think that let's just delete the old data and work upon newer data only. If we have humongous data and we want to do some statistics, let's just delete older data and work on the only smaller window, right? So you might say that, and that's how we have been justifying most of our use cases so far, and most of our organizations are justifying their existing tool in the same manner. But there are many use cases where big data plays humongously big role. So anywhere, first is when you have big data, the data uniformity is better. Okay, like, let me ask you one more question. So, if there are, if there is a big data and you compute, if you have more numbers, more ratings of a movie, so there is a small data set of movie ratings, there is a bigger data set of movie ratings, and when you compute the average rating of a movie, which one will be more accurate, the bigger data one or the smaller data one? Yes. Anybody? Deepti, I will answer your question in a minute. So my question is, simple question is that you have one very small data set, other very big data set. And what does this data set contain? It contains the movie ratings, the average rating of movies. So which one do you think? Is my voice breaking? Because Meenakshi is saying that. Is my voice breaking? Oh, okay. No worries. I'll just switch to another network connection. Let me see if that works. So stay with me. Uh, all right. All right. So is it clear or should I? All right. Good. So in case it breaks again, just let me know. I have few more alternatives to try. All right. Great. So my question was that if you have two data sets, okay. So if I have, all right. Yeah. If you have data set A is smaller and B is bigger, and it's the ratings of movies. Okay, having two columns, movie ID and rating, or let's say, yeah, ratings by various users. Okay, now if you have to compute the average movie rating, if you have to compute average movie rating, yeah, so anybody, so you have two data sets, A and B. A is a small data set and B is a bigger data set, and you have to compute average movie ratings. Which one will be better? All right, of course the bigger data set will be better. All right, bigger data set will be better, and that's what we call the law of large numbers. Okay, law of large numbers says that if you have large set of numbers, the result will be very closer to the probable theoretical answers. Okay, if you have a smaller data set, there are yeah, chances of inaccurate results. All right, so that is one big reason. That's the reason you can say that big data matters a lot, specifically in real life scenarios. When you deal with humongous data, it generally gives you better outcome. Okay, although you can truncate older data and you can just operate upon last 1 hour's values, but you will not get the real results. All right, so on the similar lines, there are many use cases. First one is in the case of web and e-commerce. Okay, the web and e-commerce is here. So you can see that, yeah, I'm removing ad targeting because that is something is not relevant in to lots of people. Yeah. So first is a recommendation engine. What exactly is recommendation engine? Let me go. So a recommendation engine is a suggestion to you. A system is recommending to you on various parameters, such as first one could be people who bought this item also bought those things. In this case, we do not know about your history of purchase. Even if we do not know the history of the purchase of the end user, we can give the recommendation of product based recommendation. We call it product to product mappings. Okay, customer who bought this also bought that. Okay, or it could be people generally wear this cloth with these things. So this is one set of recommendation. Other set of recommendation could be based very personalized. For example, at IMDb, if you rate a lot of movies, it will give you these recommendations s- which are based on other people who are similar to you in their movie liking. Okay, Netflix could be another example where the recommendation could be based on very personal information, and this is humongously useful to end user as well as to the seller, for both. Users find it useful, while the people like Netflix and IMDb are able to sell the movies. All right. Now, as a general game, you can have a look at the how do people do the recommendation. So there is some tool called Mahat, which takes the input as three columns: user ID, movie ID, and rating. You feed these three column data to Mahat, and Mahat will give you a recommendation of this form, that Kumar might like Apocalypse Now and this much. Okay, so this is technically, if you look at the what is the data in and what is the data out from a movie recommendation, you can clearly see it could be as simple as three columns of information and you get the results, or it could be as complex as that we give characteristics of each movie called features. We tell that this movie was has this genre this much longer, and was this person was the director, this person was the actor, and so on. So those are called features, and maybe that can also be utilized. But here, for the simplicity's sake, you can clearly see that what is the data in and data out from recommender. So now you can see that the more the data you have, the more the ratings you have, the better recommendation will you get. Okay, the bigger input data set is there, the better results you will get. Okay, so Thanigal's question is that, or you can, I think his name is Ganesh also. So yeah, so his question is that this is called machine learning algorithm or is it simple analytics? So this is generally called machine learning here. This is called machine learning mostly, and it could be statistics based. Okay, I was avoiding that term to in order to not to confuse people. All right. The other examples of big data use cases could be sentiment analysis. Again, the more the input data you have, the better the results you will get in case of sentiment analysis also. So what exactly is sentiment analysis? So sentiment analysis essentially is to understand the sentiment of people, of users against your brand. Are you uh, is positive? Are people liking your product, or is it going down? So what is going on? So if you have to do that kind of analysis, you need to get you need to analyze a lot of data. Maybe the sources are from Twitter or something. Once you are able to and out of this, what you need to do is classify each tweet, each message into negative and positive, and then do the summation, plot the graph where x-axis is timeline and y-axis is how much positive and how much negative. Okay, and at any given date we can say that these many people are talking positive and these many people are talking negative that very day. Okay, so this helps a lot of people, maybe the brand ambassadors, the people who are political leaders, or the people who are designed a product are selling a product. So basically sentiment analysis helps a lot of people to basically understand how are they performing. Okay, and since when you are dealing with sentiment analysis, if your product is huge, or product is very popular, then the data is going to be very huge. All right, Other than these two use cases, you have search quality. When you are working on providing a good search engine to even to your internal customers, you might have to do a lot of analysis of the data in order to give you a brilliant recommendations while user are searching using your search engine. If you have used Gmail, you would have realized that when people search in Gmail, Gmail gives a brilliant recommendation saying, are you looking for this? All right. So doing all of that might require you to churn the humongous data, and therefore, even if your search engine searches smaller data, you will have to provide you will have to do a lot of big data churning. Sentiment analysis we have already discussed. Fourth is A/B testing. Anybody knows about A/B testing? Oh, thank you, Deepthi. Let me pick up your question. What was your question? What is the hardest part of to okay? So I missed Deepti's question. I'm going through it. So what is the hardest part to balance the effectiveness of the technology using big data? So the hardest part is to start. Okay, the hardest part is to start, to convince various stakeholders. Rest of the things are easier. Okay, why I say hardest part is start, because all of these tools are designed to scale up, meaning today you have 100 terabyte of data, tomorrow you have 1000 terabyte of data. Going from 100 terabyte to 1000 terabyte will not require you to change solutions. You can just keep on using it, add more hardware. All right. All right. Okay, the voice is breaking again. Let me just connect the another thing. Okay. Yeah. So let just wait for a minute. Okay. So I'm just switching my network because I'm guessing that it is the problem with the network. All right. Yeah. Till then, I'll just go through. So your next question is, how can we integrate data? Hello? Yeah. Is it clear to you? Is it better? Hello? Hello? Yeah. Can you hear me clearly now? I think I'm not audible enough. All right, so I'm afraid that I'm not clearly audible to you. Hello. Hello. Can you hear me now? Is it clear? Hello. Yeah. Is my voice clear to you? Ouch. Looks like I'm not audible enough, or am I not able to see the answers? Hello. Can you hear me? Yeah. Hello, everyone. Can you hear me clearly now? Oh, nice. Finally, I'm able to see your answers. Good. Thank God. Yeah. You have been replying, but I was not able to see any of the answers. Okay. No worries. No worries. All right. Finally. Okay. So continuing my answer to Deepti's question. First, her question was that the first question was that what is the hardest part? Hardest part is to start up. Okay. Start getting into the big data domain. Okay. And because most of these softwares are easy to scale up, so definitely the only problematic part is to start. Now, next question is, how can we integrate big data into cloud? Okay, so it is as simple as continuing to the earlier answer where I was saying that most of these big data solutions run on multiple computers. These multiple computers could be in your own data center or somewhere else. When those computers are somewhere else, we call them cloud. All right. So, and as a matter of fact, most of the people who run their data centers are on the cloud. Okay, so they are anyway generally integrated. Most of these solutions, be it Hadoop or anybody else, they run on the cloud. All right. All right. Next is that I hope that answers your question, Deepthi. Uh, The follow-up question is, can we be able to deliver result within stipulated time? Of course, that's what is the whole purpose of any of these solutions. Okay. All right, let me again go through the next question. Ravi Teja says that does big data have to do anything with SEO? No, it doesn't. All right, it doesn't. It doesn't have to do anything with search engine optimization. Search engine optimization is a technique in which we express our website such that lots of people, lots of crawlers are able to list our website a little better than the other people. Okay, so basically improving our visibility to the search engine is what is known as search engine optimization. So that has nothing much to do with big data as such. Okay. All right. So yeah, we were talking about A/B testing when we broke, and A/B testing. Yeah, Tanu says that A/B testing is a fantastic method of figuring out what is best online promotional and marketing strategy for business. Yes. Okay. All right. Now I think I'm not missing anybody's question. If I missed anybody's question, please put it again. All right. Yes. Great. Now let me get back to the A/B testing. So the other use cases were A/B testing. So somebody has really replied really nicely that A/B testing is a mechanism of partially testing your feature. Okay, A/B testing is a mechanism of testing your feature on a small set of users first. Okay, so how does it happen in general? So do you know that Amazon.com's website runs thousands of variations parallelly? And how does it happen is that each feature, say, let me give you a better example. Do you know the button called buy now or add to cart on the Amazon's website? Say you want to change that. You believe that if you change the blue color to green color, the sales will immensely increase. Okay? So anything you want to do, so you come up with an idea that this is what is my plan, right? I want to change this. So Amazon does not restrict you, or any company who does A/B testing will not stop you from changing it. The only thing they will do is they'll tell you that you as a developer, that why don't you develop your new idea, you work on making it green, making the buy now button green, but make sure that you only run it for a small subset of users. So for that subset of users, those subset of users will see the new feature, while rest of the users will keep on seeing the older feature. Now, after some time, after running it for a day or two, you will compare the results. Are your results really bad? Meaning, people who saw the green colored buy now button, did they buy or not? If they did not buy, or the response was really really bad, you go back again, work on your feature again, and then launch. Maybe implementation is wrong, or maybe the hypothesis that it is green color that works, that hypothesis might also be wrong. Okay, so basically A/B testing is a platform or tool which help you run multiple experiments simultaneously in case of software engineering. A/B testing has been there for quite some time. Okay, it has been for quite some time, even before the software techniques came into play. A/B testing was used in case of medical terms, meaning some users will be given the real medicine, some users will be given the fake medicines, and see the adverse or correct effect on the right users. The Sometimes the users are not told whether they are given the fake medicine or the real medicine, and sometimes even the doctors do not know they are administering their fake medicine or the real medicine. So this way, so A/B testing has been there for quite some time, for various kinds of testing whether a particular medicine is correct or not. All right. Other use cases are telecommunication, where people want to do customer churn prevention, network performance optimization, and calling data record analysis. Okay, customer churn prevention can be done if you know the pattern. Why do people leave you? Why do your users leave you? And you can figure that out. I mean, a telecommunication company, a telecom, can figure it out based on what did users do before leaving your network. Okay, how many calls did they make to your customer care? What was their daily usage? Where did they live? What was the how many percent of the time were they connected to the network? What operating system are they using? And lot of other parameters you can, basically sit down and analyze what exactly went wrong. So you can do a customer churn prevention in many ways. All right. So Deepti's point is A/B testing is similar to integration testing or parallel testing. Not really. Okay. No, not really. A/B testing is from the end user perspective. It is not really to do anything with multi-threading. Multi-threading is running things parallel on your server. Okay. Here, when we run things parallel means, and whenever we do multi-threading means on both the threads we are running the similar code. Okay. Here, for when user comes into your website, you show the user a different version of the website altogether. Okay. For some user it's A, for some user it's B. All right. So it's a production time thing. A/B testing is something you do it in production on the real users. All right. It is not during the case of you are not seeking the vote of anybody in your internal. You are not doing it internal testing. A/B testing is real life testing where you show it to the end user. Your revenue might get hurt, but that revenue hurt is better because it will be smaller only. So that is why in A/B testing you start with very small users, but real users, real random set of users. All right. Is my voice breaking? All right. For Anand, it's pretty clear. And okay, good. Now my question is, so did you get what does it mean by A/B testing? So there are many such use cases where you could utilize a humongous data. So other thing you should note is whenever we do A/B testing, we are talking about millions of users. If your website has only 100 users per day, A/B testing would not give you brilliant results. It might take you maybe 15 to 20 days to run your A/B testing environment to really get any output. All right. All right. So yeah. So is A/B testing clear to everybody? All right. There are other use cases such as government and healthcare. So probably everybody is now starting to use big data. The kind of people who are talking to me right now with their real use cases, I've realized that almost every company has now started their planning into big data. All right. Now, there are many more. These people have been using the big data solution like Hadoop since 2011. Now, here are the general myths. Okay, so big data always means about. Okay, let's take a break. Who wants a break? So let's take a break for 10 minutes. All right, let's take a break for 10 minutes and then come back and then continue the discussion. All right. 8:58. All right, let's come back at 8:58. Thank you, Kelly. Yeah. Hi, can we start now? Is everybody back? All right. So going back to where we were, all right. Great. Is everybody back? Only I've got an answer from Anand. So should we start now? All right. All right. So good. Good. Now we're starting. So there are few common myths. First is big data always means data above or in range of terabytes of data. Okay. There are many use cases where even if the data is in gigabytes, even if the data is in gigabytes, it becomes impossible to churn using a single computer or using a language like R, which is single computer based. Therefore, big data is even applicable for few gigabytes of data where your problem demands so much of computing or so much of churning of data. All right. Yeah. So yeah, we were just talking about the big data. So Thanigival's question says that we were in the big data use in government sector. So there I just went through the list. Okay, probably my voice broke at that time. So the example big data customers, other than what we talked earlier, telecom and e-commerce, government is also a potential user. Government uses it for fraud detection, cybersecurity, welfare, and justice. And in healthcare and life sciences, there are multitude of uses. There are many use cases where big data is inevitable. Okay, such as health information exchange, gene sequencing, and healthcare improvements and drug safety. All right, all right. So, can you give any example? Okay, so I mean, in government, the example use case is fraud detection. Fraud detection could be of many kinds. It could be based on anti-money laundering. Anti-money laundering is a case where you compare the customer's information against. So, if you are a say financial organization, anybody who you deal with, you have to compare them against a database of terrorists released by the government. Okay, that is anti-money laundering. So anti-money laundering is one case where a fraud detection is done at a larger scale. Okay, and for anti-money laundering, you cannot do it properly unless you use a distributed computing environment or a big data solution. All right. All right. Now, in case of healthcare, there are many use cases. If you look at UC UC Berkeley Irvine, there is one big use case. What they have done is, since in healthcare, let's talk about health information exchange in first. Okay. So since in healthcare, the data is in a very complex form. Have you seen a soft copy of your X-ray? Okay. The soft copy of X-ray is a complex image and it's not easy to actually process it like an image. For that, you require different kind of software to deal with. Okay. Similarly, you have MRI data, you have various kinds of scans data, you have various tests, you have the prescriptions written by the doctors, you have the uh, ratings taken by various kinds of observations taken by the nurses. So there's a variety of forms of data, and no single database can handle it so easily. But and this information is humongous. Okay, this information is humongous. That is where the HDFS comes into play. We'll talk about it later. Next is that for figuring out why are patients being readmitted, they conducted a lot of observations. Okay. Similarly, in in case of gene sequencing, you have to generate a lot of combinations and permutations of various genes and do the simulation. Okay, and that's where the single computer is generally not sufficient in most of the healthcare solutions. That's where you require either even the supercomputers are not really sufficient. Okay, that's where the distributed computing comes into play. All right. So there are many use cases where the even drug safety, again, the A/B testings are performed on a large scale, and the data you gather is humongous. All right. So okay, now let me move on to the common myths. You can go through many use cases which are listed at a lot of places. Okay. The second common myth after the first one is big data is always about social media. It does not apply to me. This is a myth because anywhere personally I have worked, the big data was in picture. That big data was their internal data, not from the social media. All right. And next third one is it will replace enterprise data warehouse. No. Enterprise data warehouse is meant for very special purpose for the structured data or relational data. Okay, so you should not touch that. No big data can replace any EDW. Reason being, none of the database as of today provide you the relational or transactional kind of a model as provided by the relational databases. Okay, so if your data is small and can be handled using existing systems, you should do that. Okay, so mostly the big data solutions will augment the enterprise data warehouses. Augment as in they will support the data that's not fitting into EDW will be moved on to the big data architectures. All right. Fourth is it's just a buzzword, no practical application. So this is obviously a big myth because everywhere it's being used as of today. Is a new concept. No, it's not a new concept, just the word is new. Okay. As I was telling you at D shop, we did distributed computing in 2002. Okay. We were handling hundreds of terabytes of data. Okay. But we called it a grid computing that time. So there's not much of a difference between grid computing and distributed architecture or big data solutions. All right. Sixth is it will be the future. No, it is the present. Is expensive? No. Most of these solutions are open source and the hardware they run on is a commodity hardware. Is only for data scientists or is a magic? No. It's for everybody. It's not only for data scientists. We have enough hardware, we don't need it anymore. So big data is not about hard purchasing hardware. Please keep that in mind. Okay, it's actually opposite to purchasing new hardware. Whatever hardware you have, you can install big data solution onto that. So every big data solution has been designed in that way. Big data is always about Hadoop. No, it's not about Hadoop. There are multiple solutions such as we'll talk about them. All right. Now, regarding the job scenarios, I was seeing the salary trend, and it looks like Hadoop has got the highest jobs. These are from Indeed. The link is at the bottom. I'll send you this PDF. You can click on the link and go through the trend by yourself. Okay. Next is the various kinds of big data solutions. The most popular one is Hadoop. Most popular one is Hadoop. Here, it's the most complete solution. It has everything. We'll show you that. Other one is Spark. Spark is just a computing engine. It doesn't have the storage. While Cassandra is mostly like a storage, but does not have too much of computing ability. Although Cassandra supports a basic computing such as MapReduce, but not really to a great extent. Now, so if you just have to store data and do a basic computation on that stored data, and your data is not in the files form, then you can basically utilize Cassandra really well. Okay. Then there is Google Compute Engine. Now there is something called Google Compute Engine where you upload your data on Google resources and utilize Google's query and BigQuery and other tools to churn your data. But in the Google Compute Engine, the problem is that your data is outside your premises. Then you have MongoDB. MongoDB is similar to Cassandra. It provides you MapReduce or the computing one, as well as it allows you to store lots of data. Okay. So, but out of all of these, the most complete one is Hadoop, which provides everything and is a good ecosystem. Now, Vikram's question is, why does Apache have Spark when Hadoop is all encompassing? Right. So Hadoop is all encompassing in the sense that it has MapReduce. Okay. Now, Spark was a faster form of computing as opposed to the MapReduce, and that's where Apache absorbed Spark into it. Okay, so Spark will be soon part of the Hadoop ecosystem. It's already top level project at Apache, and it runs on top of Hadoop as well. So if your resources are in Hadoop, you can continue to use Spark without any new installations. Okay. So not really, no, except for Google Compute Engine, all of these are open source. Yeah. So Meenakshi, when I say Hadoop provides everything and is a complete ecosystem, I'll talk about it in detail. All right. So first, your answers to related to Hadoop will be answered here. So what exactly is Hadoop? Hadoop was created by a person called Dog Cutting of Yahoo and Mike Caffarella. So they were building a search engine called Nudge as their personal project. And they were having a huge difficulty in storing humongous data. And that's when the Google's paper on Google File System came along with Google MapReduce and Google Bigtable. So they implemented those papers in order to support the Nudge search engine which they were developing, which was sort of a competitor to Google, but still they were trying to build it in a personal time. So for building that, they built Hadoop essentially. So in the beginning, we had Hadoop file system, which is HDFS, Hadoop distributed file system, equivalent of Google file system. Then we had Hadoop MapReduce on the lines of Google MapReduce, and then we had Google Bigtable, which is similar to HBase we have right now. So effectively, Hadoop's first version was based on the papers published by Google. Okay, so it was named after the toy elephant called Hadoop with which dog cutting son was playing with. And it is a Apache licensed and is open source. And this is probably the most important reason why Hadoop is Hadoop as of today. Why Hadoop is so popular. Okay, that is the reason why. Next is powerful, it's popular, and it's well supported. All right, and it's a framework to handle humongous data. All right, now the point number H, if you look at here, it tells you that any component which is a part of Hadoop has to be reliable, scalable, and for distributed computing. All right. And Hadoop is a framework to handle big data. Now you can see that every component, that is why we will stick to the definition of big data, that every component that lies under the umbrella of big data, they all have to be reliable, scalable, and for distributed computing. All right. Now this is the ecosystem as you see it. So Gunjan's question is, just now I said you said about MapReduce, what exactly it is. So right now you can just think about MapReduce as that you want when you want to do some computing on multiple machines, you write your logic in the form of MapReduce and hand it over to Hadoop. Hadoop runs those maps and reduces on network of computer and give you the results. Okay, we'll talk about it in little bit more detail later in the second session. So Deepti's question is, what is Nudge search engine project? So they were trying to build a search engine like Google, and they were calling it Nudge. All right. All right. So uh, Ganesh, were you able to understand what was MapReduce in layman's terms? Okay. So basically in MapReduce, what you do is you write your program to churn the data, and your program is sent to the data on this data is located on multiple computers. Okay, so your program is taken to the data and run against each piece of data on different computers, and the results are combined, and then the results are combined using your reduce function. Okay, so that is probably the most simple way I can describe MapReduce. All right, so we'll go into more details later on, no worries. Now let's talk about the main components, which is Hadoop distributed file system. Okay, so Hadoop distributed file system is the base of whole of the ecosystem. The whole Hadoop ecosystem. You can see these components. We'll talk about each of these components after we finish HDFS. And Hadoop ecosystem has HDFS as the base. Now the question arises, why do we need a new file system in first place? What is the point of having a newer file system? Okay, we'll talk about this. So Meenakshi's question is, MapReduce is only for processing maps and images or any data. So MapReduce is for anything. The name does not signify that it is for only maps. Okay, map means we are mapping piece of the, if we have a huge data, we are saying some part of this data is being mapped to one machine, some part is being mapped to another machine, and so on. Okay, that's why it's called MapReduce. Basically we are mapping some data to one processor. Okay, so we'll go into the details of MapReduce dynamics in next session. Okay, All right, so let's talk about the base of the whole ecosystem called HDFS. Now, before I build it, before we go into it, we'll just build it by ourselves. We'll talk about how would you store 100 terabyte of data by yourself. Okay, if you imagine that you are living in a hostel and all of you guys plan to build a 100 terabyte store in which you all can store your movies at a central place, and whenever you wish you can watch the movie. How would you build 100 terabyte of storage? Anybody? Anyone? Meenakshi says extra hard disk. That's correct. Good. So Tanigal says that making all hard disks connected in the network and access to everyone. Good, good. Meenakshi says that store in a cloud. So we are trying to build a cloud here. All right. Gunjan says that maybe 10 terabyte on 10 different system. Good. All storage. Good. Anand says make a table of different storage of in which device can offer how much storage. Good. So Anant is saying let's make a table of different storage containing which device can store how much of storage, how much of data. So yes, that is good. Basically you are trying to build an index of the devices. Okay. All right. Brilliant. So yes, so what you are talking about is that let's take some hard disk, connect them together, and mount it on multiple computers. Make sense? So this is how it will look. This is how we generally build network attached storage or storage area network. NAS is network attached storage and SAN is storage area network. And this is how we used to build. So the general plan would be have 100 hard disks, each of 1 terabyte size, connect to the multiple computers, say, and after connecting to that, you mount these over a network such that if you have a computer and after mapping each folder to each hard drive, you will have a structure like this. You will have 100 subfolders, each folder mapping it to one network drive. Make sense? And then you can start storing the data inside these folders. All right. Now, do you see any challenges with this? No? Do you see any problems with this approach? So all you did was you connected these hard drives, 100 hard drives, onto multiple computers, and then connected those computers in the network. Then the way you map the hard drives onto each folders, each network hard drives onto folders, and you have this structure. And now you can continue to store your movies in these folders. Do you see any problem with this architecture? Anyone? So for time being, then his question is, Ganesh's question is, so here all drives from 1 to 100 is physical hard drive or virtual combination. So these are physical hard drives right now. Physical hard drives connected to different computers, but they're mounted in a network. Meenakshi says too many hard drives. Probability of one drive failing is more. That is correct. So yes, if you have too many hard drive, the chance that today On a particular day, a hard drive will break is quite high. Okay, when hard drive will crash is quite high. That is correct. Anand says that finding a particular movie, or in another words, figuring out where to store a movie and making up a plan is a really big challenge. That is good. Thank you, Anand. So if you have stored, finding a particular movie is another problem. Rajkumar says network latency. Thank you. That will be another problem. Network latency is going to be a big challenge here. Now, no redundancy, meaning in case one hard drive is is getting a crash, there is no backup plan per se. N- Tanigal says, Ganesh says that it is a series connection. If one fails, we can't access anything. Okay. That is correct. That is correct. In case the computer which is hosting this folder structure, it fails, then we can't access anything. All right. Yes. Another thing is, in case a network fails from one computer and another, nobody can access anything. Good. Good. All right. So these are few challenges as you have mentioned, that the failover and backup is missing first. Second, how will we store data uniformly? Okay, imagine that we decided that on drive number 1 we will store all the movies starting with A. Okay, after some time you realize that the drive 1 will not suffice for A, because almost all the movies, there are a lot of movies that start with A, right? Therefore, the data uniformity will not be there. Some drives will be too much busy, other drives will be comparatively free. Next is this the best value for your money? Okay. You are buying 1 terabyte hard disk. Maybe you already have hard disk lying around in your organization, or maybe you can get 500 GB hard drives cheaper. All right. Now, the next point is increasing away accessibility, meaning if all of the people are trying to watch the same movie, imagine that today we are some new movie got released and that got copied to one of the m- drives. When everybody wants to watch the same movie, the drive will be under a huge stress. Okay, which means that the drive might crash, or that computer might crash containing that drive. That one computer containing that one particular movie is humongously busy while others are free. Therefore, accessibility is getting hit really, really bad. Now, what about scaling out? What does it mean by scaling out? Okay, scaling out means scaling out means today we have 1 terabyte of 100 terabyte requirement. Tomorrow we might have 150, 200, or 300 terabyte requirement. Then will our solution suffice? Does the solution suffice? Okay, so if you scaling out will be a very big problem, because if you add more hard disk, then you will have to do a rebalancing of the data manually, and that will be a big headache. All right, that is why the HDFS comes into play. Okay, so what does HDFS looks like? Now we'll go step by step, understanding the concept and the architecture behind HDFS. So let's start with a simple part, where defining admin node and data node. HDFS, which is Hadoop Distributed File System, is designed for a huge scale, designed for storing thousands of terabytes of data without any problem. All right. So generally you have two kinds of node, admin node and data nodes. Admin node is singular while data nodes are many. As one of you was telling me that we'll create an index. So that index is what is being stored at name node. Name node or admin node is somebody which stores this information, that which file is on which computer, which file is located where is the duty of name node. All right. Name node only stores metadata. It does not store, name node does not store the actual data. All right. And all of these, so there is only one name node and there are multitude of data nodes. Okay. So name node stores data in the RAM, which is metadata, meaning information that which file is where. Also, this RAM is also stored on the disk. In case name node shuts down, the data is not lost. All right. Now, data nodes are designated for only storing the data and nothing else about the file. All right. So name node is kind of a master and data node is kind of, slaves which store the data. Now, I'm removing this question, so don't bother answering it. Yeah. Next point is that, okay. So name node also contains the folder structure, the file name, and other stuff, other information you want to store about the file. Okay. So the whole tree structure of the file system is inside name node, while the data node only contains the file. And whether name node or data node, they are essentially processes. These are essentially programs. Those are running continuously, listening on a port and waiting to answer your query. So name node or data nodes are services which run in the background. All right. That also means that admin node or name node you can run on any computer having Java, because as I was telling you, the Hadoop is written in Java and so is HDFS. So effectively you can run data node on any machine where Java is installed. Okay. Now the important part is that the files are splitted into chunks of 128 MB. Instead of storing the full file on one machine, HDFS does a little clever thing. It slices the file into 128 MB blocks. And earlier it used to be 64, but now it's 128 MB block for various kinds of reasons. Now, because of this slicing of the file, it helps Hadoop to fit the data onto a smaller disk. You can fit big files into smaller disks, and also it leaves less unused space on the disk. Okay, so if you have a disk which has say 300 MB left and you want to store 1 GB file, you cannot store. But if you are slicing the files into blocks, there are high chances that you will be able to fit a, you will be able to uh, distribute your data very uniformly. Okay, it leaves less unused space on the disk. It optimizes the data transfer. It optimizes the distribution of the data. All right. So every file is broken into blocks of 128 MB each and distributed across data nodes. Make sense to you? All right. So Gunjan, what question did you have? I missed your question. So you have admin node, data node. Admin node will store information about where is the data, while data node actually store the data. The way data nodes are storing the data is we are breaking the file into blocks of 128 MB and putting it on data nodes. Okay. Yeah, it looks like torrent protocol and inspired by torrent protocol, Anand. All right. Next is that each block, the block 128 MB block, each block is replicated across other data nodes. Meaning one copy, so each file is broken down into 128 MB blocks. So if we have, if we have, let me just increase the font. So if we have 1 GB, it will have 8 blocks. Each block is going to be multiplied by 3, okay, 3 times, and will lead to how many blocks? 24 blocks. All right. So so effectively 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 we will be storing 3 GB data instead of 1 GB. All right, if we have 1 GB file, we'll be consuming 3 GB space. Why? Because we want to keep 3 copies of each block. Okay. So this replication factor of 3, meaning 3 copies of each block, acts for the purpose is twofold. First, it makes the data available on multiple machines, meaning multiple users can access the same data parallelly from different hard disks. In case you are having a very popular file which is being used heavily, you can just increase the replication level and multiple compute the load will be divided across multiple computers. Next is, in case of a disk failure, you have a backup copy of it. The 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 replicas are stored on different machines. No two replicas of a block will be stored on the same machine, and the reason is, in case that machine goes down, both the replicas will go down. That defeats the purpose of having a backup. All right, it's like saying I'll keep the backup copy of my data on the same machine, right? We should not. Siemens, on the similar spirit, the each block is copied thrice onto different machines, not on the same machines. Okay. In case one of the data node fails, so all the files whose blocks are lost, the replica factor will come down. In order to bring up the replication factor, is the data starts getting copied. Okay. All right. Now, one thing you might be wondering, that what does it mean by rebalancing? Let's imagine that we are trying to store, okay? So how much is, let's say that we had 250, 230 GB, 230 MB file, which means 2 blocks, okay? And we call them block 1 and block 2, okay? Block 1 is having a copy of block 1 1, block 1 2, and block 1 1 3, and block 2 is having a copy of, okay, block 2 is having a copy of, say, block 2 2, 2 1, block 2 1, 2 2, and block 2 3, right? So we have, I'll just remove this. Okay, so 230 MB file, first one is how much? 128 MB, and second one is how much? The remaining one, Anybody? 102. Okay, MB. Now 128 MB is this block. The first block is copied at 3 places. Okay, and so on. Okay, is everybody with me? So let's say this is stored on node 1, this is stored on node 2, and this is stored on node 3. Similar is the case here. Okay, so block 1 1 is stored on node 1, block 2 1 2 is stored on node 2. When I say node, node means a computer. Okay, block 1 3 is stored on node 3, and so on, right? So we have these kind of blocks. Now in case, or let me say that we have node 1, node 2, node 3. Okay, so now you can see that each block is copied twice. Now in case if node 1 goes down, okay, block 1 and block 2 1 will be lost, right? But since block 2 2 is just a copy of this one, block 2 3 is just a copy of this one, and so on, right? Block so node 1 goes down and we have spare node 4, right? So data from node 2 will be copied to node 4. And what does it mean by data? Data is the e- either this or this. Okay, data from node 2 or node 3 will be copied to node 4 to to bring up the replication factor. All right, make sense? So if you have 230 MB file, if you had 230 MB file, it will have two blocks. One is 128 MB, other is 102 MB. Each block is copied to 3 times. Each part will be copied to 3 times, and effectively there will be 3 blocks containing the same data on different computers. In case the node 1, the first computer, dies, so both the blocks will have a replication factor of 2 now, which means that it needs to be copied once more. So the data from node 2 or node 3 will be copied to node 4 in order to bring up the lost data. Make sense? So Gunjan's question is, so we can replicate more than 3 times if required. Yes. You can tell Hadoop that, hey, this file is important. Can you set its replication factor to 10? Okay. So you will have 10 copies of each block of the data. So Gunjan's question is, but doesn't this require too of space? That's correct. It would require, and the reason is the disk space is cheaper than your data. As long as you are able to provide combine the drives and provide the disk space, it's okay. Okay, it's worth it. So is 3 replication minimum? No. Hadoop does not enforce such constraint. You can have the replication factor as 1 also. Okay, you can have a replication factor of only 1. If you are very confident about your hard drives, although you should not be, because hard drives crash all the time, in case you are very confident, you can utilize, you can mark the replication factor as 1. How node failure is detected by HDFS? Very good question, Anand. So the way it happens is, all these nodes keep on sending ping to admin node, or we call it heartbeat. All data nodes keep sending heartbeat to admin node. In case data node does not respond, does not give a ping to admin node for some time, admin node assumes that data node has gone down. Okay, and that's when it starts the job of the replication across the cluster immediately. Is it possible to call all the nodes simultaneously? Yes. So in case you want all the parts parallelly from, so you are trying to watch a movie and you want all the parts immediately from all the machines parallelly, you can do that. Okay, that's partly the reason why the data is decided. It uses J groups. What does it mean? So Anant is saying it uses J groups. Not really. It is an independent system in itself. All right. Now, good question from Binod. If admin node goes down, so the way the whole architecture is built, in case admin node goes down, there is always a secondary name node. Okay, so these are failure backup of secondary name node, which has exactly identical copy of whatever data is there on name node. It secondary name node contains exactly the same data, ready to serve the cluster immediately. I'm talking of high availability mode, HA mode, and everybody nowadays uses HA mode only, high availability mode, in which there is a secondary name node containing exactly the same replica of name node, and in case name node goes down, it takes the place. Okay, but it does not. Nobody accesses secondary name node until name node fails. Okay, so that backup or the mirror is just a backup or standby. It does not do anything other than keeping its data as up to date as possible with name node. Okay, and how does it do it is, name node as well as data node, all of these nodes keep on informing secondary name node with the latest amount of information. All right, moving on. Now, you might argue that the name node is the bottleneck, because the way we visualize is that user will come to name node, ask name node to give the data, name node will gather the data from data nodes and give it to you, give it back to the user. No, no, it does not do that way. Instead it works like this. The end user uses something called a driver, like JDBC driver or any other driver, the software interface. That software interface goes to HDFS or name node and says, can you tell me where is my file located? And then once a name node responds that your file is located on this server 1, server 2, and server 3. Okay, please go and get it from there. Do not bother me. I'll not read the data for you. You will have to read data directly from the data node. I Okay, so that is how name node saves itself from being swamped or being overloaded by the requests. All right. Again, this is how it looks like. It looks like a little ugly diagram. You might imagine that in a data center, you have rack 1 and rack 2. There are two racks containing these data nodes, and these data nodes are containing blocks of data. And there is name node is containing metadata such as folder name, file name, number of replicas, location of the block, how many for each file, how many blocks are, how many replication factors there, how many blocks are there in that file, and those blocks are located on which folder, which data node, and so on. So that is metadata. And the client basically talks to name node first, and then name node tells what to do. Okay. So say for example, you want to write a file, you will go to name node first to create the file. And once name node the file is created on the name node, it will not be committed unless the data is written directly by you in the data node. So you go to name node, say, hey, I want to create a file. Then you go to data node, you start writing the data. Once you finish writing data, you inform name node that, hey, I'm done. Okay. Once you say to name node that you are done, then it marks it that the write is successful, and only then it will start serving that file. And while reading the data, same thing, the command line client or the driver goes to the name node and says, can you give me the block location for this file? And then it gives the list of blocks and their locations in the network. And then your client goes to those particular data nodes and reads the data from there. All right. So you can think of name node containing the metadata as list of blocks in each file, and so on. All right. So does the admin node check the heartbeat or data node sends it? So yeah. So Gunjan's question is, does admin node checks the heartbeat continuously, or data node send signal to admin node? So data node sends signal continuously to the admin node, and yeah, data nodes keep on sending the heartbeats to the name node continuously. Okay. So name node always refresh what data node has, or we do it manually. So anything that goes to the data node, okay, anybody who wants to write anything to data node, they tell name node that they are trying to do this, and only then name node is updated. Okay. Data node, whatever data is contained in data node is not copied to name node. Okay. Name node only contain information like what is the name of file, how many blocks are there, where are those blocks located in the network. All right. Does it make sense, Ganesh? All right. Now, a quick question to all of you. If we are creating a folder, if we are creating a folder in HDFS, how many data nodes will be accessed? Anybody? If we are creating a folder, the folder does not have any file, it's just a blank folder. Anyone? So folder is the path information. Folder is not the data. Therefore, the information about the folder name is only stored on the name node, not on the data node. All right. Now Vikram's question is, how are concurrent requests for the same file block are handled? Very good question, Vikram. As we talked about a block is located on multiple machines because it has replications. So effectively, a block can sustain a three requests in parallel for the same block. Okay. Similarly, if you are watching a movie, so if some people would be reading the first block, some people would be reading the second block, and some people would be reading the third block, and that way the load is distributed across the cluster. Make sense, Vikram? All right, now let me describe to you the details the about the Hadoop ecosystem. Okay, so we talked about HDFS just now. All right, we talked about HDFS just now. In this, that's the main component. Then we have import and export tool. If we want to import the data from other resources to HDFS, Flume is a brilliant solution. If you have multiple web servers running and copying the data, Flume is good. Then we have NoSQL data store, where we store the data, uh, structured data, where we have columns and just like we have Excel sheet or database. For that, we use HBase. HBase can store HBase is for billions of rows and millions of columns. It's a brilliant way of storing the structured data. All right. Then is the compute engine. Okay. On top of HDFS is the compute engine called Yarn. Yarn is the basic computational engine which can execute any program on any machine without swamping, without overloading a particular node. Okay, so Yarn is specialized in executing anything on any node. But what exactly need to be executed is dictated by MapReduce and other tools like Spark. Okay, Spark, MapReduce, they run on top of Yarn. Okay, Yarn means yet another resource negotiator. On top of all of this is Hive. Okay, using MapReduce, you break down your logic in terms of maps and reduces, and then send it to Yarn and execute it. Similarly, in case of Spark, you break down your problem statement into the constructs supported by Spark, and then you hand it over to Yarn. Now, you cannot keep on dividing your normal processes into maps and reduces. Instead, you use a SQL query processor called Hive. You write your logic in SQL query the way we have been traditionally doing, hand it over to Hive. Hive will convert your SQL query into MapReduce and execute it via Yarn and all of that. All right. Now, sometimes the Hive query language is not well optimized. At that point of time, you can utilize Pig Latin. Pig Latin is good for analytics. None of these, Hive or Pig, they don't provide you the row-wise editing of the database. All right, you will have to do it directly in HBase. Now you have Mahout. Mahout is a big library of various machine learning related functions which you can utilize and which runs on top of Hadoop. So any recommender basically runs on top of Hadoop using MapReduce, but you will just execute the library provided by Mahout. All right. Once you have a big project, if you have a big project containing multiple of these components, and also if you want to import data from MySQL or Oracle, you can utilize Scoop, where you will copy the data from structured sources onto HBase, Hive, or HDFS. Okay. Now, if you have a big project, you will be using maybe first import data, then clean the data using MapReduce, and then churn the data using Hive. And once all of that is done, run Mahout in order to generate recommendations. And once Mahout has generated recommendation, put those recommendations back into a structured data. So as you notice that in this exercise, you might have maybe 10 components running in in a chain or in parallel. For that kind of a job, to run these things in parallel or in sequence, you will use something called Oozie. Oozie is the workflow engine, just like Apache Ant or Maven or Makefile. You- So just like that, you have Oozie. Oozie is also a scheduler which runs periodically as well as data dependent. We'll talk about all of these components, plus we will talk about Zookeeper. All right. Now, here is the question from Ganesh. How the load is distributed depends on the traffic maximum. Yeah. So load is distributed based on if first request it goes in round robin. First request is coming, it goes to the first data node. Second request coming, second data node containing the copy of the data, and so on. Okay. Now Binod's question is when I should use which ecosystem. All ecosystem purpose are same but in different way. Oh, I did not get. So are you asking that in this ecosystem what component is used in what sense? Yeah. So as you will go across, so here these are the tools to import data. SDFS is for storing the unstructured data in the form of files and folders. HBase is for storing the data like a database in the tabular format. Yarn is not something, Yarn is a platform component, you don't interact directly. MapReduce is for the time when you want to do programming in Java or Python or any other programming language. In case you want to churn your data using Hive, meaning SQL queries, and you can use Hive and so on. So as we go across the session, the 11 sessions, you will have the thorough clarity on what to use when. Now, Vikram's further question to the concurrent problem is, with concurrent requests, again, if there are more requests than number of replicas, then some mode of caching or concurrent, yes. In case there are number of requests in parallel for a particular block, then then will there be caching or connection pool? So you will have to design it by yourself. HDFS does not provide any kind of caching or connection pooling. Okay, you will have to do it by yourself, or you could basically change the number of replica to suit the number of users, concurrent users. All right, you can increase the number of replica factor. So Deepti's question is, why yarn override any methods? I did not get your question, Deepti. So Binod's question is, we can do the same thing by Spark as we do it in MapReduce. Yes, almost everything you can do with MapReduce you can do in Spark. Just that MapReduce does not consume too much of RAM, while Spark consumes a lot of RAM. So it might make your cluster really, really busy immediately. What is the program extension used in Hadoop? So you can execute any program. There is no extension configuration. And so you need to understand how to execute the program. Then you will have more clarity on the extension thing. Okay. And moreover, the extension is mostly the concept from Windows, where Windows try to figure out based on extension what to execute. While in Unix, the concept is little different. Vinod's question is, what is the purpose of Spark? Spark is really, really fast computing. MapReduce works in batch wise. We create our program, hand it over to MapReduce, and say, whenever you are free, please do it. Okay. While the psyche of Spark is, I'll do it right away. If I'm not able to do it right away, I'll give you error. So that's the psyche of Spark, and that plays a very big different role. Okay. So Gunjan's question is, do we have facility to program in C++? Yes. So using streaming, MapReduce streaming, you can program in C++ with MapReduce. Okay. So with the Spark, you can use so with so Deepti's question is yarn does not override any method as you explained like in MapReduce. You can program in any language. Yes. So in MapReduce you can program in any language. Similarly in Spark you can program in Python, Java and Scala. Right now only these three languages are supported, while in MapReduce you can program even in Shell, even in Perl, even in existing binary or okay. So that way. All right. So is there any ID or suite available for basic to try? Right now, the way we provide in Cloud Labs, you can basically go to the web and from the browser, you can access these components and interact with them. Okay. So Deepti's question is which language is most efficient? That will be a very big discussion, so I will avoid it. Okay. But right now we are more focused towards Python than Java. Okay. But in this course it will be great if you guys go through Java basics. All right, we have a free session, free recorded session for Java available on our website. If you register it will appear in your my courses. Okay. All right, so this is a little bit about Cloud Labs, and so this was a free sessions for all the candidates. In case you want the full session, for second session onwards, our classes are starting from 2nd May. All right, 7 a.m. And every Saturday, Sunday, it will be 3 hours class, just on the same time like today. And there are going to be 11 classes, which means 33 hours. The course fees is 18,747. Okay. So you can sign up for the full course and we will go into the details of all the full ecosystem of Hadoop, and we'll make sure that you understand each and every component and understand when to use what. All right. So you can reach us on these numbers or you can just drop us an email at reachus at no big data. And this is my personal number. I am in a very bad network zone, so you may not be able to reach me, but you can reach these two numbers. All right. All right. Any other questions? Yeah. You all will get a recorded session link. No worries. But it'll take around 6 hours to get uploaded and optimized. Okay. All right. So feel free to get in touch if you have more questions. We will second session onwards will start from 2nd May. Basically, 2nd May will be the same session what we have attended today, and from 3rd May, I think 3rd May is the correct date. Let me just understand. Yeah, 3rd May will be the second session. Okay. All right. Thank you, Minakshi. If you really like the session. Okay. Thank you, Deepti. I'm happy that you find sessions fabulous. So Atanu's question is, what are the basic things? Okay, what are the basic things need to learn Java for Hadoop? Java basics are sufficient, Atanu. You can just go to our website, No Big Data, click on register and register. After that, you will see under My Courses, whatever Java is required. I have created videos for our students so that they have no difficulty in understanding Java. Okay, although not too much of Java is required, if you are comfortable with the basics of programming constructs such as this is while loop, this is for loop and all that, then you should be able to handle the course. So Anand's question is that do we have course on weekdays? Not really. We have not planned for weekdays yet, but probably the next month onwards in the May there will be one weekday course started. Okay. Okay, Ganesh question is that what are the opportunities for analyst, developer, and infrastructure? Mm, there are many actually opportunities for all of them. The link which I have shared for the Indeed.com, you can have a look at that. That will give you a better picture at it. Okay. There are quite a few opportunities in big data domain as of today. Okay. So if you are analyst, you don't have to program in Java or anything. Hive and Pig will Hive, Pig, and understanding HDFS overview and understanding MapReduce will be sufficient basic, and plus running Apache Spark and all will be sufficient for you. If you are a developer, then you need to understand how to programmatically do things. And if you are infrastructure, you need to know how to install various components. All right. Thank you, Gunjan. I'm happy that you find the session nice. Okay. So Neerav's question is that what are the good books to learn Hadoop and clear CCDH Cloudera certification? The book I recommend is generally the Definitive Guide to Hadoop. Okay, this is a good book, and you can use that book to go for the full course. Okay, that's a all right. The fourth version has come now. Okay, okay. Fourth edition, not revision. Fourth edition. All right, great. Thank you, Atanu. I'm happy that you found course helpful. Thank you, Ashwant. You found the session good. So yeah, Yashwant's question is that how to switch existing relational database to big data. You will have to use a tool like Scoop to move data from relational to big database. Okay. Deepti's question is there any session for Power Builder? So we have not yet planned for Power Builder yet, but maybe in future. Okay. So Kiran's question is, does this course cover any certification? So the way we have prepared the whole course is in tune with all certifications available. Effectively, both Cloudera and Hortonworks certification, we have created a course such that our course is suitable for both these certifications plus the real life applications. Okay. So Meenakshi's question is, I need to discuss with you on career opportunities in big data domain. So the career opportunities are big. There are lots and lots of y- you know demand in the big data. You can see on Indeed.com and Naukri.com, and yeah. But you can drop me an email with your specific question at reach us at no big data if you have any questions. All right. Thank you, Ganesh. You found it happy and helpful. And all right. Okay. Meenakshi's point is that I'm engineer basically, but in sales domain all through 9 years. Okay. Yeah. You can call me on personal number. Yeah. No issues. All right. Okay. So yeah, you can call me on my personal number. You have my number. Okay. So Javadi Kiran's question is, can you suggest the path for developer to enhance? Yeah. So the only way you can enhance as a developer is solving a real life problem or going through the available code on GitHub or similar sources. All right. That is the best path for developer to enhance. All right. Thank you, Nirav. I'm happy that you find it helpful. So yes, Ganesh, Scoop does data copying from one location to another, and does it really well. All right. Thank you, Deepti. Have a good day, you too. Hi, Hirdesh. Uh, do other products like Terracotta, Jennifer also are same as Hadoop? Not really. They solve a very different problem. Okay. So yeah, you can just email at reach us at no big data. Okay. And if you have any questions, feel free to uh, contact us. Okay. So Hirdesh, am I able to answer your question? All right, great. So if you have any questions, whatever you have, wherever you're stuck, let us know. All right. So HDFS directly linked to Tableau, MicroStrategy, R for visualization. So these all tools like Tableau, they have started supporting HDFS in the background. So when you have data in HDFS, you can actually present in Tableau. MicroStrategy, I'm not sure. I may have to study a little bit. While R for visualization, you can use R, but only if the data you can copy it back to R. Okay, the problem is that R can only handle the data in the memory. R yet is yet to read the data from HDFS. Okay, thank you, Vikram. I'm happy that you found this informative. So I'm making note of few of your questions. All right, so that I can, yeah. All right, so all right. So feel free to ask any questions at reach us at no big data. We try our best to answer your questions, or you can be on our forum. You will find our forum uh, useful. Okay. Okay. You can ask questions here, whatever questions you have. Okay. All right. Thank you very much. It was a great session and looking forward to talk to you guys. If you have any doubt, any question, feel free to drop us an email at reach us. I'll just type it here. Reach us at nobigdata.com. All right. Great. See you in the sessions and have a good day. Bye bye. I'll mute and now we'll exit. If you have any questions, let me know. Do you have these manuals in email, YouTube, anywhere? Which manuals are you talking about, Ganesh? Yeah. So this PPT I'll be sharing you anyway. Okay. All right. Bye bye. Have a good day. Bye Anand. Bye Atanu. Bye Hirdesh. Bye Javadi Kiran. Bye Ravi Teja. Bye RT Avasthi. Bye bye Sujit. Bye Thani Gavel. Bye Yashwant. Stay in touch. If you have any questions, feel free to reach us at No Big Data. No issues, yeah? All right. All right, Yashwant. So, Yashwant, if you have any question, drop me an email. All right. All right. Bye bye. Have a good day.